This conference will now be recorded.
Today, let us start off with one more new topic, that is multi-threading. So what is multitasking? Opening multiple applications. Like in my case, I've opened browser, notepad, GoToMeeting, Eclipse like this. So if you are listening, if you are typing a document in Microsoft Word, along with that listening to the songs, means both applications are running simultaneously. So that is multitasking. Then what is a thread? So the meaning of thread is like, if you take Gmail, Gmail, we call it as a task. Gmail is what? It's a task. In this Gmail, how many compose windows we can open? We can open how many compose windows? Multiple, right? We can open multiple compose messages. So every compose message what we are opening, since they are part of this Gmail task, this we call them as what? Threads here. These are your threads. So threads are part of one task. Threads are what? Part of one task. Right? Then when you are doing attachments, when we are going with attachments, how many attachments we can do? Multiple attachments, right? Multiple attachments. So you can attach file 1, I can attach file 2. When file 2 attachment is going on, we can attach file 3, and we can even type the subject and body of message. So these attachments are part of this compose message. Then we call it as thread group. So what is thread group? Collection of threads only we call thread group. And the main use of going with multi-threading is to increase performance of application. I need not wait one thing should get completed. When first attachment is going on, until it completes, then only I can attach second, like that. It is not there in Gmail. So I need not wait one thing should get complete. So the main use of going with multi-threading is to increase the performance. So how to define a thread is like, a thread is a lightweight process under execution within a process. So if you take Gmail as process, the lightweight process like attachments, compose messages are your threads. And the use of going with multi-threading is used to increase the performance of application. And one more good example is like GoToMeeting. In this GoToMeeting, it's a task. I can show the screen, it's a thread. I can record the class, it's a thread. I can speak with you, it's a thread. All the things I'm able to do simultaneously means this GoToMeeting is also multi-threaded. Now, let me elaborate more on this. With an example, a simple basic example. Like when you run a Java program, it enters into main method. In this main method, we want to find sum of even numbers. So we invoke the method SumEven. We want to find sum of odd numbers, then we call the method SumOdd. Now when you are defining the method, we'll say int SumEven. Here we write some logic. Which returns the sum of even numbers. We define SumOdd. Here we write some logic which returns the sum of odd numbers. Now when you run the program, it will go to what? First main method. From main method, whenever it sees SumEven, whenever we invoke SumEven, the control will jump from here to here. The control will jump to this method. And when the total method is executed by CPU, when the total method is completed, then only the control will go back to the main method. Again, when you call SumOdd, again the control will jump to SumOdd method. And when the total method is completed, then only the control will go back to the main method. Means in the case of traditional programming, in the case of ordinary programming, when we invoke a method, until the total method is complete, CPU will not come out. The control will not come out from that method. Let us suppose when some event method is getting executed by CPU, in between the CPU may be free. So when it can be free, when your method is doing some IO operations, input output operations, means like reading some value from keyboard, displaying something on screen. So when we do some input output operations, the CPU will be free. Even though the CPU is free in some event method, it cannot allocate time to some odd method. The CPU has to sit idle only. In the case of traditional programming, the CPU has to sit idle. Means the performance will be degraded. Now, if you make use of threads, if you make some event as a thread and some odd as one more thread, then when we use threads, when some event method is getting executed by CPU, it can even come out and allocate time to some odd. So sometimes it is going to allocate for some event, sometime for some odd, sometime for main method, sometime for some event, sometime for some odd, sometime for main method. Means in the case of threads, CPU will not sit idle at all. It can even come out of a method before it gets completed, and it can even allocate time to other methods also. So in the case of threads, CPU will not sit idle. So when CPU is not sitting idle, then the performance of your application will be increased here. Got it? The main thing of thread is like we should not waste the time of CPU. CPU should not sit idle here. That's the main purpose of going with multi-threading. Got it, everyone? Any questions? I will show everything practically to you. Now, how to create threads in Java? That's the main thing to understand. Creating threads. How to create threads in Java is just we have to create a class, some class name, class myThread, extends thread. Or let me write a document like how to create threads is by creating a class, which extends thread class, or by creating a class which implements runnable interface. We are having two ways of creating threads. Either you can extend thread class or implement runnable interface. Today, let us see thread class, and next class will go with runnable interface using thread class. What to do is just to create a class like myThread extends thread. Understand carefully. This thread is concrete class. Concrete class means fully implemented. Fully implemented means not abstract. Opposite of abstract class only, concrete class. Means does not contain any abstract methods. But thread class does not have any abstract methods. Now, if any class extends concrete class, do we need to override any methods compulsory? Do we need to override the methods compulsory? No, right? Only when we extend abstract class or only when we implement interface, then only we have to override the abstract methods. But here we are extending concrete class means fully implemented, does not have any abstract methods. So nothing to override in this class. Compiler will not say anything if you are not overriding any method. But as a programmer, we have to override a method, run method. As a programmer, we have to override the run method, and in this run method, we have to go with the logic of your thread. You can even call other methods like some event, some mod also. Then, now how to invoke this run method? That is the main thing of threads. How to invoke run method is we have to create object of your thread class, myThread t equal to new myThread, and we have to invoke run method only by using start. So only when you say t dot start, it's going to create a thread, creates a thread. The object will become thread and invokes run method. Whenever you want to create a thread in Java, we have to invoke which method? Start method. So only when you say start, the object will become thread, and internally it is going to invoke a run method. Okay. So this is the main thing. So if you call t.run, it will become ordinary programming. If you say start, then only the object will become thread. Then CPU is going to allocate separate time for your thread here. So everything we'll discuss. When I say start, what will happen? When you say t.run, what will happen? We'll see everything practically. Now, let us go with one important diagram, state transition diagram of a thread. Thread states. State transition diagram of a thread. A thread undergoes totally 4 states. They are new, runnable, blocked, and dead. New, runnable, blocked, and dead. These are the 4 states of a thread. When can we say the thread is in a new state is when we create object of your thread class. So when we create object of your thread class like my thread t equal to new my thread. When we create object of thread class, the state of your thread is new state. Then when it goes to runnable, it's like when we invoke start method by using object. When we invoke the start method, the thread will go to runnable state. Understand carefully here. So when we say start, what I said, it is going to invoke run method. So when we invoke start method, don't assume that it goes to run method immediately. It will go to run compulsory, but at what time it goes to run, that is not in the hands of programmer. Our work is only to push the threads into runnable state. Then whenever CPU allocates time for your thread, then only it enters into running state. It's going to invoke the run method. So optionally we show here running state. Running state means when it enters into run method. So runnable is like ready to run, waiting for CPU time. When CPU allocates time, then only it enters into run method. This concept is important for us. This is optional to show. No. The next one, blocked state. When it goes to blocked state is when your thread is using IO operations. When your thread is going with IO operations, then it goes to blocked state. Or when we use sleep method, if you say sleep of 1000 means 1000 milliseconds, means for 1 second the thread will go to block state. Or when we invoke the method wait, so when we call the method wait also, it will go to block state. Then when it will come back from block to runnable is when it comes back is after IO operations. After IO operations. When we invoke sleep, after sleep means once the time is completed, automatically it will go back to runnable state. If I go with wait, we have to call the methods notify or notify all. Notify or notify all. So more about this blocked state we'll be discussing in next class. Now Coming to the next one, date state, from wherever it may be, we can terminate a thread using stop method. Using stop, we can terminate the thread. So more about this diagram we'll see practically. Once we start writing the programs, we can understand more of this diagram. Now, let us see what are the methods present in thread class. Methods of thread class. We're having the methods like thread, current thread. This current thread method will return the current details of thread, like the name of the thread, priority, and thread group. We are having start method that internally invokes run method. We are having set name to change the name of the thread, which takes string as an argument. String get name, which returns the name of the thread. Set priority. Set priority, which takes integer as an argument. Priority means like importance. When we give more priority, your CPU is going to allocate more time for our thread. Less priority, less time for our thread. Get priority. Sleep method, which takes long as an argument, and toString method. So, toString method belongs to object class and it is overridden in thread class. Now let us discuss all these methods using an example program except sleep method. Sleep method we'll discuss in next class. For today, let me discuss the remaining methods. So for that, let us go with the program. Thread methods demo. So this program is mainly to elaborate the methods of your thread class. So from this program, we'll get a basic idea. We'll get a basic idea of multi-threading. And in the next program, which we discuss tomorrow, we get the full idea on threads. So let me discuss the methods. From the program, whatever I discussed up to now, it will become like a recap. To store thread related programs, let us create a new package, threads. In this threads package, create a new class, thread methods demo. Main method. This program is mainly to understand the methods of thread class. Now, how to create a thread? I said just we have to create a class, some class name, my thread, extends a thread. How to create a thread? Just we have to create a class, extends a thread. And what is it? Thread is concrete class. Concrete means fully implemented. Opposite to abstract class only concrete. So when a class extends concrete class, do we need to override any methods here compulsory? No. We need not override any methods. But as a programmer, we have to override a method run. As a programmer, we have to override the method run. And in this run method, we have to go with the logic of your thread. The code behind your thread, we should write in run method. Now, let me just go with a simple code. I am a thread. How to invoke this run method? In the main method, in the main thread, main is also called as thread. In the main thread, we have to just create object of my thread equal to new my thread, and we have to invoke run method only by using start. So when you say t.start, it goes to run method and this message will be printed on screen. See, when you say t.start, it's going to create a thread. The object will become thread, creates a thread and invokes run method here. When we run, We are getting the message I am a thread, which indicates the start method internally invoking run method, which is proved by displaying this message. Clear up to here, all of you? Don't invoke run directly. We have to invoke run only by using start. Then only the code will be multi-threaded. Now let us see the methods. The first method, thread t equal to thread dot current thread. What is the use of current thread? It returns the current details of thread like the name, priority, and thread group. Let me print this t value. When you print t value, see the output giving the name. So when you say t dot start, a thread will be created. It goes to run. We are taking the current details of thread and printing. So what is the name? When you say t dot start, it's going to give the name thread fn0. And 5 is the priority. 5 is what? Priority. And main is the thread group. Because when you run the program, the first thread what it creates is main. Under that we are creating subthreads. So we call main as what? Thread group. So when you say t dot start, what's the name it is going to give? Thread fn0. Thread fn0. When you say t dot start, it's going to give the name thread fn0. If you say t1 dot start, then what's the name it's going to give? Thread fn1. It's going to give the name thread fn1. If you say t2 dot start, thread fn2. Thread fn2. Like that it continues. Now let me create one more thread object. My thread t1 equal to new my thread, and we'll say t1 dot start. T1 dot start. So in this program, how many threads are there in runnable state? When we run the application, how many threads will be there? First main thread, then t. What's the name given to t thread? Thread fn0. Then t1. What's the name? Thread fn1. To avoid confusion, let me remove main thread. Now when you run the application, out of these two threads, which thread will get executed first? Out of these two threads, which thread will execute first? T or T1? Take it here when we run. So which thread is executing first? T. T thread is executing first. Let me run the code again. Now see, T1 is executing first. Now let us run the code again. Again T. Let us run T only. T. Some keep on running. Now say T1. So is it guaranteed? No guarantee. No guarantee. So which thread will execute first means no guarantee. So our work is just to push the threads into runnable state. How to push the threads into runnable state? Using start. So here we have pushed T and T1. T and T1. So for which thread it's going to invoke run method first, that is not guaranteed. That's the point here. So runnable state means ready to run, waiting for CPU time. But out of these two threads, for which thread your CPU is going to allocate time, that is not in the hands of programmer. That's the point what I discussed in the diagram. Now, instead of start, if you say run, instead of start, if I invoke run, then how many threads are there in this program? See here, how many threads? Only one thread main. Only one thread main, because it's a ordinary programming. It's a ordinary program. When you say t dot run, it will go to run method until the total run is over, it won't come out. If you say t1 dot run, it will go to run method until the total run is over, it won't come out. Okay, it's a ordinary program. So we have to create a thread only by using start method. Right? When you say start only, the object will become thread and it's going to invoke run method. Right? Now let me discuss the methods here more. So let me remove this part. More about multi-threads we'll discuss in the next class. For now, let us concentrate only on one thread now. So what is the output we are getting when you are printing T object? Yes. So who is taking care of printing the output in this format? Who is printing the output in this format? ToString method. So whenever you print the object, whenever we print object in SOP, which method will get invoked implicitly? ToString method. So who is taking care of printing the output in this format? ToString. Let me elaborate more on this method, more on this output. So in this thread-0, this is the name of the thread. This is the default name. 5 is the priority of the thread. This is also default priority. Main, we call it as thread group. Thread group means collection of threads. Let me elaborate more in depth of this. When you come to multi-threading hierarchy, the topmost interface under multi-threading is interface runnable. The topmost interface under multi-threading is runnable. And in this runnable, it goes with only one abstract method, run. Contains only one abstract method, run. Then your class thread, whatever I'm writing, all internal code, your class thread implements runnable. When class thread implements runnable, then as a rule of interface, the run method has been overridden here. Whatever the run method we are having, we have to override that method as the rules of overriding as we are implementing this interface. And this run method is empty method. Empty method means no code inside. Does not have any code inside. It goes with other methods like start method. When you invoke start, it makes your object as thread. And finally, it is going to invoke run method. So start internally invokes run method. It goes with other methods, what I have mentioned above. These all methods present in your thread class. In thread class, it goes with 3 final variables. In thread class, it goes with what? 3 final variables. They are public static final int min priority. Min priority is 1. Public static final int normal priority. Norm priority is 5. Public static final int max priority is 10. Means for a thread, we can give priority between 1 to 10 only. So this point is very, very important. And the default priority, what it's going to give 5. So whenever you create a thread object, how it knows that it has to give 5 priority? It will come to this thread class, takes the normal priority value and gives that priority over here. See here, you can see you are having thread class C. Thread class belongs to which package? This thread class belongs to which package? If you are using any class or interface without writing import statement, what is the point I said? The class or interface belongs to java.lan package. See here, when you keep mouse pointer on this, you can see java.lan package. And if I want to see the profile of thread class, means the methods present in thread class like that, just to keep mouse pointer on thread class, press control key, and you can see the option open declaration. Then you can see the profile of thread class, thread.class. See here, it is implementing runnable. Okay, it's implementing runnable. and see it's having three final variables, and see the methods current thread like that. So min priority, normal priority, and max priority. Now let us come to the methods. By default, it's going to give the name thread fn0. We want to change the name, then we'll say t.set name. T.set name will say my thread. We are changing the name of the thread. If you print the object, now the result will be thread. The name of the thread is my thread. Priority 5, thread group main. Now I want to pull out only the name of the thread. To pull out only the name of the thread, we'll call the method t.getName. T.getName will return the name of the thread, in our case, my thread. Now we want to change the priority. The default priority is 5. We want to change the priority, then call the method t.setPriority as 8. T.setPriority as 8. Now, if you print the t object, now the output will be thread, my thread, priority 8, and thread group main. Now we want to pull out only the priority of thread, then we'll say t.getPriority, which returns the priority as 8 to us. Here now, when we run, same output what I've given in comments. Clear up to here, all of you? Any questions? Right? Now, understand carefully, very, very important one. If I give priority as 18, I'm giving priority as 18. But what is the point we discussed? We can give priority between 1 to 10 only, but we are giving priority as 18. Then see, when we run, so it's going with what? An exception, illegal argument exception. It's going with what exception? Illegal argument exception. So for a thread, we can give priority between 1 to 10 only. So I'm writing this point. If the priority is less than 1 or greater than 10, then it will throw, it will throw illegal argument exception. Going to throw what exception? Illegal argument exception. Let me document this. If the priority is less than 1 or greater than 10, then it will throw illegal argument exception. This illegal argument exception, is it a checked exception or unchecked exception? Illegal argument exception, is it a checked exception or unchecked exception?
Unchecked exception.
Unchecked, because we are getting error during runtime. We are getting error runtime. So all runtime exceptions are unchecked. Then illegal argument exception is a subclass of which class?
Exception.
All are subclasses of exception class, but one more is there in between. Yesterday I have
Runtime
given this point.
exception.
Very good. Runtime exception. So if you are getting a runtime exception, means it's a subclass of which class? Runtime exception class, and categorized as unchecked. Simple blind rule. We have to remember. So what is that point? Illegal argument exception. Exception is a subclass of runtime exception class and categorized as unchecked exception. Comes under as unchecked. So these points are very important. Now, one more point. if I invoke start method one more time, t.start, I'm invoking t.start one more time. See what is going to happen? It's going to throw what exception? Illegal thread state exception. Illegal thread state exception. We cannot invoke start method multiple times. Okay. So if start method is invoked multiple times by the same thread class object, then it throws illegal thread state exception. So we cannot invoke the start method multiple times by the same thread class object. If you are trying to do that, it's going to throw what exception? Illegal thread state exception. And this is also subclass of runtime exception class and categorized as unchecked exception. Same principles applies. Okay. Any questions, anyone up here? Right. So let me stop for today. Tomorrow we continue and we complete the remaining part of threads. Like we'll discuss how to create threads using runnable interface. Then we go with the synchronization concept and inter-thread communication. And we'll be seeing one more good example initially, like how CPU is allocating time for your multiple threads. That's the main thing to discuss tomorrow initially, right? So before you join, please recap and join so that tomorrow's class will be easy for us to understand, right? Yeah. Thank you all.
Raj, one question here.